All right, hi everybody. Today I want to talk about function notation, okay? Because I have a suspicion that a lot of people aren't quite clear on what exactly it means here. So let's just take a quick function here. Let's say you had y equals, I don't know, 3x plus 1, okay? So what we've got here is a relationship between the independent variable and the dependent variable, okay? Where y is the dependent variable. But remember that what's going on here is y and x both refer to numbers, okay? I choose a number for x, I plug it in, multiply by 3, add 1, and I get the y coordinate here. In function notation, we simply replace the y, okay, with f of x. Okay, now this right here takes the place of the dependent variable in this expression here. Now I know for a lot of people that looks a little bit weird, and your first thought is, well, why the heck would we do that? What do we gain by that? All we're doing is making it a little bit more complicated. But actually, this is a step forward in your mathematical knowledge here. Okay, what we're doing here, what we're starting to do here, is make that step towards doing mathematics with functions. Okay, not just with variables that represent numbers, but with variables that represent relationships between values. Okay. Now I want to talk about this a little bit more clearly here to make sure that you understand why function notation is so valuable to us. I want to talk about what the two different pieces mean here. Okay, because I understand right now, I mean, when we have the f there, and I know someone's going to say, I know what f stands for. F stands for function. Yeah, I get that. When we're using f because it's a function here. But the f in this case here, in this specific case, refers to the rule. In the notation here, okay, the f refers to the rule that is being applied. And the rule here is multiply the independent variable. Okay, I'm not even going to say x here, because that's not what the f refers to. It means multiply the independent variable by 3 and add 1. That's what the f stands for in this use of the function notation, okay? It stands for the rule that we're applying. Now, the bracket x here, okay, the x in parentheses, I don't know if you're seeing that here. I'll just adjust this a little bit. Okay. Anyway, what that stands for here is the independent variable is x. Okay. Now I know that's not quite clear, but that's what we're saying here. The independent variable in this case is x. So now what I'm going to do here is erase this. Keeping that same definition in mind, I want to talk about what's going on here when we use this in a different context. Okay, let's say, for example, that f of x, we're still going to stick with the 3x plus 1. If I now replace the x here, and I'll do it this way, if we replace the x with, let's say, 5, okay, the f still means that rule, multiply the independent variable by 3 and add 1. In this case, though, the independent variable is now taking on the value of 5. So this becomes 3 times the independent variable, which is 5, plus 1. And the answer is 16. Okay, so the dependent variable, this whole thing represents the dependent variable, is 16 when the independent variable is 5. Okay, you can change this up. We could make this, for example, a, f of a. Again, the rule, the f rule, okay, is multiply the independent variable by 3, add 1. In this case, though, the independent variable is a. So this becomes 3 times a plus 1. Okay, so I hope that makes sense here, that this is not f times x. And when I plug the a here, like I see people make this mistake all the time. They'll go, okay, well they'll put an a kind of around where the x is, but they put the x in there as well. And that's not the intention of this notation. Now, this allows us to do a couple other things. Okay, if that's the case, then we can write something like this. Let's say f of a plus 1. Okay, now I want to stick with the same function here, because you can make whatever function you want, but I'm going to stay with the same function. This means multiply the independent variable by 3 and add 1. In this case here, the independent variable is a plus 1. So this is 3 times a plus 1 plus 1. 3 times the independent variable, that's the independent variable. Now I know what someone might say here, well wait a minute, no, that's a couple of terms there. Just bear with me for a moment, I know where we're going with that. But this is taking the place of the independent variable in this notation, and then we would expand that out, and we would get 3a plus 4. Okay, so f of a plus 1 is 3a plus 4. Okay, now granted, when you look at the end result here, well, perhaps it makes more sense to think about this as having an independent variable of a, right? Well, what we do is is basically we're going to change the way we label this here. This is a plus 1. Okay, the independent variable in the use of it right here is a plus 1, but the final answer doesn't really look like the original expression for f, because what we've done here is we've created another function where the independent variable is a. So h, okay, h as a rule of a is going to be equivalent to f evaluated where the independent variable is a plus 1. The resulting function here is 3 times the independent variable plus 4. And that's essentially how we get around that. Now, this, and the reason why function notation is so cool and it's so important is because this suggests a different type of arithmetic that applies to functions and a different rule that applies to functions. Because what's going on here, this a plus 1, well, we might call that a different function altogether. This might be the function, sorry, I probably don't want to do that. This might be the function, for example, g of a, okay, becoming a plus 1. And so in essence, I'm plugging a function inside a function. So when we make the transition over to function notation, what we're doing is we're creating a different level in your understanding of mathematics. We're moving away from variables that represent numbers and moving on to variables that represent relationships between numbers. And this creates another operation that we're seeing right here. And this is what we call function composition. Okay, now I'm not going to go into a lot of detail on that. All I want to get across to everybody right now is the importance of function notation and why we do it. Because at first glance, when we first explain it to people, you would say f of x simply means y. That's kind of where we stop. But it's so much more involved than that. And it's important that you kind of get a glimpse as to what's going on here. It's allowing us to extend our mathematics just that additional step. Okay, so this is kind of the beginnings of that. Anyway, I hope that helps. Or perhaps this was just another mathematics monologue and nobody's listening.